section 4.4, logarithmic equations and functions. So we're going to be learning how to find the domain of a logarithmic function, x and y intercepts, graphing them, solving applications. So the first thing here is finding the domain of a log function. So remember from chapter 1 that, and beyond, that a domain is the values that we can plug into a function are valid, that make it true, right? So if we can't plug something in because it makes the denominator 0, or it, what's the other thing? That's fractions. Or it causes us to take the square root of a negative number, then those are not part of the domain. So logarithms also have this restriction because they can't be 0 or negative. It has to be greater than 0. Okay? So values for which the argument of a logarithm is a positive number. The argument is what we call the expression inside the logarithm, what we are taking the log of. So you can see the argument in parentheses here, here, and here. So let's find the domain of each one by taking the argument and setting it greater than 0, not equal to, because it can't be 0. So we're going to go argument is greater than 0, and then we solve it. Okay, so this first one, we would have x squared plus 1 is greater than 0. So x squared is greater than negative 1. So I don't know if you are thinking about this, because you've got to put your thinking caps on sometimes. If we plug any number in for x and we square it, what kind of number do we get? Well, we're always going to get a positive number. And a positive number is always going to be greater than negative 1, because 1 is a negative number. So this is going to always be true, which means the domain for this particular function is all real numbers. Okay, number 2. This plus 1 doesn't change anything because the range of a logarithm is all real numbers. So adding 1 to it just shifts the whole graph up and doesn't change the range at all. Okay, so this is the part we're worried about for the domain. So again, we take our argument 1/2 x plus 1. So I'm just trying to help you understand that this plus 1 outside of the parentheses is not part of that argument. Okay, so that's greater than 0. So then we have 1/2 x is greater than negative 1, which means x is going to be greater than negative 2. I just kind of, cross multiplied, or 1/2 is the same as dividing by 2, so the opposite of that is multiplying by 2, right? So this domain, x is greater than negative 2, would look like parenthesis negative 2 to infinity. And if you're not sure, you can always plug in numbers and see if it works. Like if I plug in a negative 2, I get 0, and I can't take the log of 0. But if I plug in something bigger than negative 2, like a negative 1, then I get negative 1/2 plus 1, which is a positive 1/2. And we can take the logarithm of positive 1/2 because it's bigger than 0. If we plug in 0, we get 1, and we can do the log of 1, right? If we plug in 1, we get 1.5, and we can take the log of that. So anything greater than 0, we can take the log of, which is what this tells us. Alright, this one's a little more complicated simply because it has the denominator that can't be 0, in addition to this whole thing that can't be 0. So let's kind of look at that. So first of all, we know x can't equal negative 1 because we can't divide by 0. Even if it's the argument of a logarithm, we still can't divide by 0, right? So that's one detail to keep in mind. And then we're going to go x over x plus 1 is greater than 0. Well, this isn't as simple to solve as this one over here was. That's because this is a rational expression. So we learned about these in chapter 3, where we actually need to test intervals and see what works and what doesn't. So we need to look at our critical values. We already found one of them by thinking through the fact that it can't equal negative 1. That's technically one of our 2 critical values. Our other critical value is going to be 0 because the numerator because we're looking at x-intercepts to see where the graph would cross the x-axis, and it would be 0, because if we plug in, like if we set the numerator equal to 0, then x equals 0, right? So our critical values are 0 and 1. So that means we're going to do intervals from negative infinity to 0, and 0 to 1, and 1 to infinity. And we need to actually test them to see what works and what doesn't. So let's plug a negative 1 in here. So negative 1, oh, we can't do a negative 1. I just totally messed this up, didn't I? 2, back up, scratch that. Go back to here. So we have negative infinity to negative 1. Easy mistake. Good thing to kind of see. Things to be careful of, because then they're not going to work out. Alright, so let's try negative 2 instead. So negative 2 over negative 1 would be a negative divided by a negative, which is a positive 2. So that makes that true, right? And then from negative 1 to 0, we have to do a fraction, like negative 0.5. So negative 0.5 over positive 0.5, that's going to be a negative 1. Not that the value itself matters, just it's going to be a negative divided by a positive, so that's a negative number, which makes it false. And then in this interval, let's try 1. So 1 over 1 plus 1 is 1/2, which is positive, which is true. So the domain for this problem is negative infinity to negative 1 union 0 to infinity. Because that's where, if we were to graph it, we would have our graph be above the x-axis, and the values would be positive, and therefore we can plug them into a logarithm. Does that make sense?